Hi, this is Luke Robbins. I'm just going to give you an overview of UnionFS, which was my topic for a research paper to look into. So in terms of motivation, there are a lot of times when it's useful to have multiple different file systems available on a single machine. And instead of having them as separate sort of branches, as like different subdirectories, it's useful to kind of merge them, particularly when you've got a lot of sort of similar files or files that are kind of related in some way. But when you've got a lot that are duplicates, you'll only present a single version of that file to sort of help keep things straight in the user's mind, and also use this sort of file system to make changes to files when kind of incrementally developing something without affecting the original files, so that you kind of preserve those. So UnionFS is not really an independent file system type like ext2 or something like that. It's more like a service that implements a union mount for other file systems, and I'll go into what a union mount kind of is and what it looks like. UnionFS is sort of an intermediary between the user and the file system. It will intercept sort of operations, it will perform its own housekeeping, and then it will present a merged view to both the kernel and the user to kind of take care of that and just present that single logical view. And it's useful that it does it with the kernel as well, so that it can be employed by applications without having to worry about what the file system is, or what the kernel is actually seeing. So just in terms of nomenclature, it's called, each individual directory and file system is called a branch, and those are what's merged. So in terms of setting it up, it's a kernel module, so you have to download and compile it and sort of get it set up with the kernel, and then once you use it, you do have to mount it like any old file system, but instead of mounting on a device, we're actually going to mount it right on top of the directories that we're going to use. So in terms of this mount operation, we're going to mount type UnionFS using directories /first and /second, which you can see are separated by that colon. And we're going to create a new directory called /mnt/merged. And none is just used in place of the device name that we would normally use for a mount operation. So just to give sort of a rundown of alternative ways of accomplishing sort of a similar operation, is you could just have separate mount points for your separate file systems. So if we've got these two file systems, image1 and image2, we can mount them on separate places, so mnt2 and mnt1, which are in /temp. And so anytime you wanted to perform an operation or use these files, you would just have to refer to them by their respective names. So if you'd have to refer to /temp/mnt2/ file2.txt or something like that. And another thing you can do is you can already mount multiple file systems on a single mount point, but it doesn't merge them, it just uses the one that was mounted on that mount point latest. So in this case, if we mounted image1 to test mount and then mounted image2 to test mount, the only one we're going to see is image2. Until we unmount it, at which point we will then be able to see image1. But as you can see, you can only see each respective file system's files at a single time. So obviously that is not optimal. So in terms of the view that you get from UnionFS, merging directories and files sort of look like you would expect if you just literally laid them down one on top of another. If you can think of it as, I've heard described as kind of the overhead projector transparent, slides. If you put one on top of the other, you'll see what's underneath, and then you'll also see what's on the latest sheet. So, you would see the individual directories and subdirectories kind of alongside each other, and it's only if there are sort of collisions that it has to do more complicated operations to have that working. So, for instance, if we have, two directories and have the same file with the same name, it's only going to show one of those files to the user, and the other one is kind of just going to be ignored for the time being. And any changes that are made, relative to that file will be made in the context of the one that, that we're seeing. But how do we know which one, of those files is the one that we're actually going to use? And that comes up next. So precedence is an important topic for UnionFS. It's user-defined ordering, so basically whichever one you want to be the most higher priority one is the one that is used in those operations. So if we mount a directory called first and second into a single merged directory, then the one that is first in that list of directories is going to have higher precedence. So first is listed before second, and so that directory first has precedence. So once again, going back to our example with a file called samefile.txt, it's going to be the version that we found in /first. So /first /samefile.txt is what we'll see in /mnt/merged. And if we reversed it, then the opposite would be the case. In terms of other collisions, if we have a subdirectory with the same name, then we just kind of recursively work on that subdirectory the same way we did originally. So if we have /first /subdir /foo1 and /second /subdir /foo2, then we'll have a single directory under mnt, which is going to be mnt merge subdir, which is going to contain foo1 and foo2. And once again, if we had two files of the same name, so if there was a second file called foo1, then the version that came from /first /subdir would be the one that we use. So how this relates to Docker, one of the great things about Docker is that everything we need is contained with this image, but the process of actually creating an image through sort of incremental changes and developments means that we could have multiple duplicated files and a lot of sort of different versions of things when we only want kind of the latest version and we want to see just that single final version. And so UnionFS actually uses this merging capability so that we only have a single file in the finished product or the latest product when it comes to an image. And the only thing that gets stored in sort of a new layer as we build the image is the changes that we've made. So if we've modified a file or updated a library file that's being used, then we're just going to see that that is the difference, and then that's what we're going to use. So another important sort of concept that's used to kind of complete the picture here is copy on write. So it's often used with read-only file systems. So let's say you've got a CD-ROM that you want to use and you have to patch it. You can't actually make changes to the read-only file system, but you can employ copy on write. So essentially what this will do is it will make a copy of a read-only file system or read-only files, and then it will create a read-write version of this sort of file system, which you can then modify as you see fit, and use that for whatever application you have to do. And obviously the original read-only version is not modified, and that is the integrity is maintained, but you can make changes. And so this is useful, kind of in the context of the previous slide. As we're developing these layers, we're storing the changes, and we've got sort of a read-write version. We take the lower layers, which are read-only after we develop them, and we create a read-write version, make our changes, and then save that as a new version, which is the topmost layer and contains everything we need. And another benefit of copy on write that I've read is actually being able to tweak the existing library files at runtime. So if you've got maybe an old image that has some library files that don't quite work anymore, it will grab what it needs, make those changes, and employ those library files in its actual current instance. But at the same time, the image that you've used that you're running is not changed. And here's just one final image that kind of gives you a look at how this copy on write works and what it looks like when we've got these two directories merged here. And so this is looking at, we've got two file systems, image 1 and image 2, where image 2 has a read-only file system. And we're saying that, can we modify the contents of this? And we can. So while the original file 2 is read-only, what we'll do is we'll make a copy of that file and make it writable and make the changes and then put it in our merged file system, which is test_mnt. And so if you make those changes and then try and view it, it will you'll be able to see it. But so if you if you look at temp/test_mnt/file2, then you'll see those changes. However, if you tried to print out /temp/just_mnt2/file2, you would see the original version unchanged. And here's a couple sources, and if you have any questions, I would be happy to answer them. Thanks.